continuing finding limits algebraically. Yesterday we could just plug in and that was the limit we got. Today we're going to run into a situation where we plug in and it causes a problem. Yesterday, what did we say those two problems were?
Getting zero in the denominator and indeterminate.
Whatever word that's zero. Indeterminate fraction.
Form. So 0 over 0 gives me indeterminate form, and a number over 0 is something different we'll talk about later. Today it's mainly the 0 over 0 indeterminate form is what we're looking at. Last year there were three things that we could do whenever we ran into indeterminate form. What were those three things? Multiply by the conjugate. Factor and cancel.
Rewrite.
Multiply
It's something very, very difficult.
Something canceled.
And all of this stuff should have something to cancel. Whenever you get 0 over 0, you should have something to cancel.
Okay, factor, conjugate, and
What happens when you have a fraction within a fraction?
You get rid of the fraction of the fraction.
How?
multiply by the
Yeah,
denominator.
Multiply by the common denominator. Those are the three things that we're going to do today. So let's get started.
Sure.
Let's say I have the limit as x approaches -1 of x squared minus 1 over x plus 1. And we're really not going to do it today, but what should I do every time I'm trying to find a limit?
Plug it in.
I should plug it in and see what happens. Today, they're all going to give you 0 over 0. Since it gives me 0 over 0, of those three things I have, three choices I have, which one do I need to do here?
Factor.
Factor. And it should be pretty easy. Okay? When am I going to multiply by a conjugate?
When
When I have a radical. When am I going to multiply by the common denominator? When it's a fraction with a fraction. So if I don't have a radical, I don't have a fraction within a fraction, what's my option?
factor.
Factor. So that's what we're going to do here. So how does x squared minus 1 factor?
X plus 1, x minus 1.
Then what happens, Jasmine?
Cancel out the x plus 1.
Cancel out the x plus 1. Which leaves me with that. And what do we always do after we cancel? Plug it in. So I plug in -1, and it ends up giving me -2. Now, I want you to do it just like I did up here. The limit needs to stay there until what happens?
You get the actual limit.
Until I plug in. So the limit needs to stay there until I'm actually plugging in where I'm going. Question on that one? Garrett, you good?
Good.
And on this one, I have the limit as x approaches -3 of x squared plus x minus 6 over x squared minus 9. Again, the first thing I should be doing is plug it in. When I plug in, that gives me 0 over 0. Okay, Amelia, of my three approaches, which one do I need here?
Factor.
Factor, very good. All right, how's that top factor? Anybody?
3 and 2.
X plus 3, x minus 2. How's the denominator factor?
X plus 3. X plus 3 is cancelled.
X plus 3's cancel.
Shut the door. Shut the door.
Alright, so I canceled, and then Ryan, as soon as I cancel, I always need to do plug in. So I plug in -3, gives me -5 on the top, and that gives me -6 on the bottom.
5, 6.
So my limit is 5, 6. What does 5, 6 tell me about my graph, Leslie?
That's the number, the y.
As I'm headed towards the x value of -3,
5, 6 is your y value.
5, 6 is the y value I'm headed towards. Okay. My next problem, I have the limit as x approaches 0 of the square root of x plus 5 minus the square root of 5 over x. Again, the first thing we should be doing is plugging in 0. When I plug in 0, that gives me 0 over 0. So, Garrett, what should I do? What should my approach be here?
Factor?
Don't want to factor. Courtney? What's that called? Conjugate. Multiply by the conjugate. Garrett, what's the dead giveaway that tells me I need to multiply by the conjugate?
Dead, yeah.
Yeah, what's the dead giveaway that I should be multiplying by the conjugate?
You have a negative. You have a lot in the numerator and there's an x in the denominator.
I've got square roots. I've got radicals. Radicals tell me I need to multiply by the conjugate. Now remember that I only want you multiplying what? What's the only thing we should be multiplying?
The front and the back.
Be more specific. Right, but in this case, I only want to multiply the numerator together. Why?
Oh, because you
You guys aren't giving me my
Just cancel out the radical.
I only want to multiply the numerator in this case because that's the conjugates. You only multiply the conjugates together. You don't multiply the other part. So if I multiply the conjugates together, that's going to give me x plus 5 minus 5. On the bottom, we do not multiply it out. We leave it. So you only multiply out the conjugates part. Don't multiply out the other one. So what do I end up with in my numerator? Don't these go away and I just end up with x? And then these x's can cancel? So that gives me 1 over the square root of x plus 5 plus the square root of 5.
Then do you plug in?
Now I plug in. Why do I know to plug in now?
Because you canceled out everything.
Because I canceled something out. You always plug in after you cancel out. So if I plug in 0, that's going to give me square root 5 plus the square root of 5. What's that?
2 square root of 5.
2 square root of 5. Good. So my limit is going to be 1 over 2 square root of 5. Questions on that one? Okay, I have the limit as x approaches 0 of 1 over 3 plus x minus 1/3 all over x. So I'm dealing with the fraction in the fraction scenario, which means I need to do what to approach it? Not the reciprocal.
The
common denominator.
Common denominator. So that would be what? What would the common denominator be?
It looks 3 plus x times 3.
3 plus x minus.
It is 9 plus 3x, but we don't want to use 9 plus 3x.
3 plus x times 3.
That's what we want to use. All right. So in the numerator, I do this times that. The 3 plus x's cancel and leaves me with 3. Then I do this times that. The 3's cancel and leaves me with 3 plus x. In the bottom, we'll leave it as 3x times 3 plus x. Any questions there? Okay.
Plus x.
Yeah, that's what last hour said. Last hour wanted to cancel out these 3 plus x's.
You
Can
can
I do
do it
I
because
distributed
you
that
multiply
negative
through,
x.
3x is distributed.
Right, I cannot cancel out because
You're
this
multiplying.
isn't being multiplied by anything. Remember, if you're going to cancel, what you're canceling has to be multiplied times something else. If it's not being multiplied times something else, you can't cancel it. So this 3 plus x up top is not being multiplied by something else, so you cannot cancel it. It's got to stay there. So we'll distribute the negative. My 3's are going to cancel and leave me with a negative x on the top, and that gives me that.
Now you can plug in.
I can't plug in yet because I haven't canceled anything.
Sorry, you just simplified.
I just simplified the top. But what can I cancel? X.
Okay, now you can.
So that gives me negative 1 over 3 times 3 plus x. Now I can cancel, which gives me negative 1 over 9. So the three approaches there when we get 0 over 0 are factor and cancel, multiply by the conjugate and cancel, multiply by the common denominator and cancel. Those are your three deals there. Now I want to look at a couple of the trig limits and then we'll be done for today. There are two special trig limits that we need to have memorized. There's kind of two forms of the first one. The first one is the limit as x approaches 0 of sine of x over x equals, sorry, that's not 0, it's 1. That's 1. Okay, the limit as x approaches 0 of sine of x over x, that limit is going to be 1. And the same thing over there, if you take the reciprocal of sine of x over x and get x over sine of x, that is also equal to 1. The reason we need to know these special trig limits is that if I plug 0 into sine, what do I get for sine of 0? 0. And if I plug 0 in for x, I get 0. So that's a 0 over 0 situation. So I need to know that that is equal to 1. And obviously the reciprocal is also equal to 1. The other one, is the limit as x approaches 0 of 1 minus cosine x over x is equal to 0.
But I forgot what the property is that we learned last year, but the sine of x just means 1 minus cosine of x, right?
Sine squared.
Those are the
Pythagorean, yes, those are Pythagorean. But it's got to be squared to be used to use.
Oh yeah,
Pythagorean.
they have the two.
All right, now something you need to notice about these special trig limits is that they are only special trig limits when you're approaching what x value? 0. They only work when you're approaching 0. If you're not approaching 0, you're not using a special trig limit. There should be another way to do it. Now, if you look at this one again, I plug in 0. What's cosine of 0? 1. I get 1 minus 1 on the top, which gives me 0. I plug in 0 on the bottom. So it is that 0 over 0 situation. All right, now let's do a few examples using those. All right, my first one is the limit as x approaches 0 of sine of x over 5 times x. What do you guys think?
1/5.
1/5 is going to be my limit. How do you come up with 1/5?
There's something with the 5 and just picking up
What about the bottom?
Well,
Okay, all this is, usually whenever you're using the special trig limits, you want to rewrite it to where it looks exactly like one of them. So if I rewrote it, I could have the 1/5 times sine of x over x, right?
yes.
And then we know the limit of this thing
1
is equal to 1, and the 1/5 is just a what?
fraction.
Constant coefficient.
Constant.
So if I've got a constant coefficient, it's just that coefficient times whatever my limit is, and that gives me my limit. So that's how we end up getting this to be 1/5, because the limit of the trig function, sine of x over x, as we approach 0 is 1, and 1 times 1/5 gives me 1/5. That's how we get that.
So does that mean on the other one, is this always 0? On the cosine one?
If you can manipulate it to where you get a 1 minus cosine over x, then yes, it's always going to be 0.
Okay.
But you have to get it manipulated to where you can find one of those in there.
Okay.
Okay, this one is the limit as x approaches 0 of x over sine of 4x. This one's slightly different than the last one. Because where was the coefficient located on the last one?
In front of x.
It was in front of x. Where's my coefficient here?
In the trig function.
It's in the trig function. Can I take anything out from the inside of a trig function?
No.
No, the inside of a trig function must stay unless I use a formula. And I'm not using a formula. Here's what you need to know though. If I want to use this, I can always use it as long as this and this look the same. So if I can make those two things look the same, it doesn't matter if it's sine of 100x over 100x. It's always going to equal 1. The limit of it's always going to equal 1. So knowing that, and coming back to my case, if I have the limit as x approaches 0 of x of sine of 4 over sine of 4x, what kind of manipulations can I do to get it to where the top and the bottom are the same? I can't multiply by just 4. What do I have to multiply by?
Sine.
4 over 5. 4 over 4. Sorry. So I need to multiply this by 4 over 4 to be able to get the top and the inside of the trig function to look the same. Now, I don't want to move both of these 4s to the inside. Which is the only one I want to move to the inside? The top one. So I really want to rewrite this like that. Because now I have what I want. I have this and this being the same. And once those two are the same with x over sine of x or sine of x over x, and we are approaching 0, that means that goes to what? That is the limit of 1. So then I just have 1 times 1/4, and my limit ends up being 1/4. Alright, I have the limit as x approaches 0 of sine of x over 2x. Now let's start with what we need it to look like. What do I want it to look like?
The whatever, like sine of 7x over 7x. Do you need a common?
Just hang on, just hang on. I just want you to answer that first question. Don't think past that. What do I need it to look like?
The
Same.
same.
Right, so tell me. What does it need to be? No, you're thinking too much. Tell me what it needs to look like on the inside. I don't want it doesn't need to be sine x over x in this case, because what's inside of sine? 7x. And remember, I can't change what's on the inside of sine. So what do I want it to look like if I can't change that?
Sine of 7x over 7x.
Sine of 7x over 7x. Alright, so that's what I want. So I'm going to leave that, and then I've got to do some manipulations to be able to get it the way I want. Alright, so the first thing I need to do is get rid of that 2. What can I do with that 2 to get rid of it?
Take it out.
Take it out. I can take it out. So I can take out that 1/2, and my 2 is taken care of. But I also need to do what else? Put a 7 on the bottom. And if I'm going to put a 7 on the bottom, where else do I have to put a 7? A 7 on the top. And the one that I don't want on the inside, let's just go ahead and put it outside. Now I have manipulated. How can I check to see if I manipulated it correctly? What can I do?
Is that really?
You're on the right track, but what can I do to make sure the manipulations I have were correct?
Should
The 7s and the
Here's what I can do to check it out. If I distribute these back in here, I should end up with what I started with. So check that for me. If I multiply the 7 back in, and if I multiply the 1/2 back in, do I end up with where I started?
Yes.
Yes. Because if I take the 7 back in, it's going to cancel this 7. If I take the 2 back in, the 2 is going to end up down here. So you can always check to see if you did it correctly by multiplying it back in and getting what you started with. If you didn't get what you started with, then you did it wrong. Now that I have manipulated this to where these two things are the same, that means this limit is equal to 1, and I have 1 times 7 over 2, so my limit is 7/2. How about now? Any better? Bring it out. Alright, here, if I plug in 0 over 0, if I plug in 0, I'm going to get 0 over 0. Okay? Now, what tells me I might want to use one of my special trig limits?
We got 1 minus cosine x.
That's not what I'm looking for.
Sine of x squared. Yes,
X approaching
That's it right there. Everybody hear what Justin said?
Yeah,
x approaching
The fact that I'm dealing with trig functions and I'm approaching 0, that's what tells me I might be wanting to use a special trig limit. Okay? And I see two things here. I see the sine of x and I see the 1 minus cosine of x. So I probably need to see if I can get both of them lined up. Okay? Can I manipulate it to where I get both of them?
I guess so, because you're moving it.
Okay, how can I do it? I can do sine of x over x, and I can do 1 minus cosine x over x. I can get both of them.
So is it
My answer is just going to be
0?
0. Because the limit of this thing is 1, and the limit of this thing is 0, and 1 times 0 is 0. Alright, this time I have the limit as x approaches pi over 2 of cosine of x over cotangent of x.
You cannot use the product.
I cannot use the special trig limits. Why?
Because X is not approaching.
I'm not approaching 0. But when I plug pi over 2 in, I still get 0 over 0. So if I can't use the special trig limits and I still get 0 over 0, what else can I do?
Factor, maybe, I don't know.
Right, but I'm dealing with a trig function, so I'm going to have to do something different.
Cotangent, change it to sine and cosine.
There we go. Change into sine and cosine. That's usually a good way to go. So we'll leave cosine alone on top. What do you want to change cotangent to? Cosine over sine. Good. Now what situation am I dealing with?
You're gonna have to multiply
Fraction of the fraction. So what do I need to do to handle that?
by common
Multiply by the common denominator, which is sine of x. So in my numerator, that's going to give me cosine times sine. What do I end up with in my denominator?
Cosine.
Just cosine.
And that cancels.
They do. So I'm just dealing with sine of x. And since I just canceled, what should I be doing on my next step?
Plugging in.
I should be plugging in, which gives me sine of pi over 2.
1.
And sine of pi over 2 is equal to 1. So the limit, as x approaches pi over 2, cosine of x over cotangent of x is 1. So if we're dealing with algebraic functions and I run into 0 over 0, what are my three options?
Factor,
Factor,
conjugate,
common
denominator.
denominator, I'll multiply by the common denominator. If I run into 0 over 0 with a trig function, there are really three different options there. Well, we'll just call it 2. If I'm going to 0,
Change it.
special trig limits. Try to change it into a special trig limits. If I'm not going to 0, what do I want to do?
Change the term.
I want to manipulate it and try to get something to cancel and then plug in. So that's what you're working on.